So silver chloride is an insoluble salt which can be prepared by reacting aqueous chloride with silver nitrate. Then they are saying, describe how the dry and fairly pure sample of silver chloride can be prepared in the laboratory. 4 marks. So this one requires us to explain. Describe how the dry and fairly pure sample of silver chloride can be prepared in the laboratory. So we are going to go to the spaces. So we're going to use this space, that is for C2. So for C2, we are answering question E. That is question A. So C2A. So here. So how is it? So 1, mixed aqueous. So mixed aqueous solution of sodium chloride, which is NaCl, and silver nitrate, which is silver is Ag, NO3, silver nitrate, in a beaker. So mix aqueous solution of sodium chloride and silver nitrate in the beaker. Then white precipitate of silver chloride forms. Okay, then now what happened? I can even okay, white precipitate of silver nitrate forms. Then filter the mixture. So filter the mixture using filter paper and of course and a funnel. Using filter paper and a funnel to separate Ag chloride, which is silver chloride precipitate, and wash the precipitate with distilled water. Finally, dry the precipitate in an oven. So, what is the question again? Let us go back. Describe how the dry and fairly pure sample of sodium chloride can be prepared in the laboratory. So here is the process. That is C1. C2, we are answering question A. Mix the aqueous solution of sodium chloride. So aqueous solution of sodium chloride and silver nitrate in a beaker. White precipitate of silver chloride forms. Filter the mixture using filter paper to separate silver chloride precipitate and wash the precipitate with distilled water, and finally dry the precipitate in an oven. So this is the process. This ends you 4 marks. Let us go to the second question now. So for a second question of C2, write the net ionic equation for the reaction. In one include state symbols. So for this reaction that is occurring in the first part, the reaction first is sodium chloride, which is aqueous, plus that is the silver nitrate, which is the aqueous. This results into the formation of silver chloride, which is aqueous, plus sodium nitrate, which is also aqueous, These are the products that are formed. Now, the big question here, we are told to write the net ionic equation. So net ionic equation, we know that, is this balanced, please? So we write from the balanced equation. So this is balanced. So sodium chloride aqueous plus silver nitrate, which is aqueous, then resulting into silver chloride, which is the aqueous, plus nitrate, that is sodium nitrate, which is the aqueous. So we split the one that has the one that are in aqueous. We split the one that are in aqueous. Okay, so here this is not in aqueous, please. This is in solid. So we split those that are in aqueous. So this side, the one that are in aqueous is sodium chloride. It's going to be aqueous, that is sodium chloride, plus chlorine or chloride ion, that is aqueous, plus Ag, that is aqueous. Okay, that is the aqueous. Then plus nitrate, that is the aqueous. Then on the other side, this one remains Ag chloride, which is solid. Then we split this one, aqueous, that is that. Then plus nitrate, which is the aqueous. So now you cancel out what is common on both sides. So sodium and sodium. Chloride, do you have chloride on the other side? No. What is common here? Nitrate, nitrate. What remains? Chloride ion, which is aqueous, plus Ag, okay, aqueous, then result into which is Ag chloride, which is the solid. So this is the net ionic equation. All right, I guess there's no problem up to this point. We are going to question C now, of C2. Use your equation in B to calculate the number of silver chloride expressed or expected. Use your equation in B to calculate the mass of silver chloride expected if 1.7 gram of was reacted with excess sodium hydroxide. So expected, we are calculating the theoretical yield. So this is the question C. Now, here they are saying expected mass of, from this equation, expected mass of sodium chloride, I guess. Yeah, expected mass of silver chloride. Mass of silver chloride expected. 1 point of silver nitrate was reacted. So we are forming the equation of silver nitrate. So silver nitrate, Ag nitrate to Ag chloride. Okay, so want to find the mass. Now here we are going to use what we call mass to mass. We find the molar mass of this one, we treat it as mass, and also that one as mass. So the molar mass of Ag nitrate, Ag is 108 plus nitrogen is 14 plus oxygen, there are 3 of them, 48. This one should be able to give us 108. Is it 108? This is 108, please. Not 180, 108. This should be able to give us 170. Confirm as you are going through. So this is 170. And some of you might be asking, where are we getting 170? 170 is just the molar mass of silver nitrate. Nitrate has a mass of 108. Nitrogen has 14. Oxygen, there are 3 of them, 48. So we have 170 gram of silver nitrate from, what is the mass of Ag chloride? 108 plus 35.5. This is giving us 143. So 143.5 gram. So 170 gram of silver nitrate react to form 143.5 gram of silver chloride. Now, what about 1.7 gram. We are given here. They are saying, calculate the mass of silver chloride expected if 1.7 gram of silver nitrate reacted with excess. So 1.7 gram, how many of, or what is the amount of silver chloride that will be produced? So cross multiply. So we are going to have 170 x or gram, x is equals to 143.5 gram multiplied by 1.7 gram. So this divide 170 gram divide 170 gram. This x is equals to 143 multiplied by 1.7, then divide 170. Should be able to give us 1.435 gram. Confirm if that is what you're finding. Otherwise, this is the mass of Ag chloride produced. So this is what we call theoretical what? Theoretical yield. Okay, so now that is what, or that is how we calculate this question. Then calculate the percentage yield if 0.95 of silver chloride was obtained. So this is the amount obtained, which is the actual yield. So actual yield. So to calculate the percentage yield, we are going to go, that is this question what? Is it question C? Question C, question D, the last question. So we are going to say T is equals to percentage yield is equals to actual yield divide theoretical yield multiplied by what? 100%. So what is the actual yield? 0.95 gram over theoretical 1.435 gram multiplied by 100. Okay? Multiplied by 100, able to find 66%. Confirm if that is the answer that you're finding. Otherwise, that is what we needed to write on this C2 question.